All right, let's do some more kinematics problems. So let's say now I'm on a cliff. Okay, so I'm on some mountain or cliff, and I have a ball, and I'm just gonna drop this ball down. So I'm gonna call this a drop the ball. That's not neat. Let's rewrite this. So, drop the ball type of problem. So you're gonna read problems that say you've dropped something, right? It's a ball, it's a penny, doesn't matter. But when you see this word dropped, this creates a little bit of confusion in life. Oh, and here's our ground. So I'm going to explain how to approach this. And let's say this is 10 meters high, right? So we have a ball 10 meters, and we have just, quote unquote, dropped it, okay? So that's all the problem tells you. And it's asking, what is the final velocity? So what is the final velocity of this ball? So first of all, let's clarify this. This used to confuse me, and this might sound very silly, but when you drop a ball and they ask for final velocity, I was like, wait a minute, isn't the final velocity 0, right? Once it hits the ground, you're not moving. You have no velocity. So I was like, hello, the answer is 0. Clearly, that was very naive of me. When they say final velocity in these type of problems, they mean what is the final velocity right before it hits the ground. So like right there, right? Like it doesn't mean the actual final velocity, which is like 0. It doesn't move anymore. But what it means is right before, okay? So it might sound silly, but it confused me, so I just want to clarify. Final velocity means right before it hits the ground, that instant right before, what is its final velocity? So this is all the problem gives you. So it's a kinematics, right? We're describing motion. How do you know it's describing? Velocity, distance, time. These are all describing. So anytime you have a kinematics problem, you write your 6 things down. Acceleration, v initial, v final, x initial, x final, and time. And since we're actually going in the y direction, technically it's actually going to be, whoops, this is actually y initial and y final. You know, just to be technical. So it's a good idea to actually orient which direction am I describing my motion, right? Am I going in the x direction or am I describing in the y direction? So we can actually, maybe we should start clarifying that from now on. So in the y direction, I'm going to talk about these 6 things. It's acceleration, v initial, blah, blah, blah. Okay, so what is the acceleration of the ball in the y direction? And you might initially think they didn't tell us anywhere in the problem. However, when you are in the y direction, there is a mysterious force in the universe called gravity. And gravity is this mysterious force in the world that just pushes everything down, right? I mean, we're clearly not floating in the air, so it pushes everything down. So gravity is a force that is pushing this ball down. Okay, and it only, obviously gravity only pushes things in the y direction. It actually only pushes things down. So that's why in the last problem, when we had our car moving in, left to right, we didn't say there was an acceleration due to gravity, because gravity is only pushing down. So whenever you're dealing in the y direction, you have to now think about this mysterious force that they don't necessarily tell you, right? But we all know exists, so that's why they expect you to know it. So when gravity pushes down, first of all, it's pushing down, right? So what is the acceleration that gravity causes this ball to accelerate? Well, gravity is going to cause this ball to accelerate. So let me write it here. It's going to cause this ball, to accelerate at 9.8 meters per second. Okay? Some guy, his name's Newton, important dude, he's the one who figured this out. So you don't have to derive this. You just have to know this number. 9.8 meters per second. So gravity is going to cause this ball, which is starting at an initial, let's write this, it's starting at an initial velocity of 0, right? And you might also say, well, they didn't tell you that it starts at 0 meters per second, but when you drop something, drop is your clue. So this word drop in English translates to, hey, we are not really pushing it, we're just dropping it. So if we're dropping something, its initial velocity was 0. So we'll come back to that in a second, but let's just say that, right? So if I'm starting at 0, gravity is going to cause the velocity to increase every second at 9.8 meters per second. So after 1 second, when it's down here, it's going to have, 9.8. That's going to be its velocity. And then at 2 seconds, it's going to be 19.6, whatever. However, notice, gravity is pushing, it's causing this ball to accelerate down. So down means negative, right? So again, there's nothing inherently negative about going down, but it's just saying, so the acceleration due to gravity on this ball is negative 9.8 meters per second. Now, you can memorize this. I use that word loosely, memorize, because I don't like memorization for physics. I think it messes you up in the end. But if you want, you can technically memorize this, that gravity, it is true, that gravity will always push things down at this negative 9.8 meters per second. It'll cause things, I should stop saying push. It causes things to accelerate down at a rate of negative 9.8 meters per second every second. So at 1 second, you're at negative 9.8 meters per second. At 2, you'd be at negative 19.6 meters per second, and then so on and so forth, okay? So, yeah, so you have, this is your acceleration, and this is uniform. So it is on every, so if I have a really heavy ball, let's say this is very, very heavy, gravity is still going to be causing it to accelerate at negative 9.8 meters per second. And if you're really light, let's say you're like a dot, you're still, gravity is going to push down at, so it's down, so it's negative, and then the rate is still negative 9.8 meters per second squared. All right, so we're pushing down, we're accelerating at negative 9.8 meters per second squared. What's doing this? Gravity's doing this. So sometimes they'll say acceleration, and then they'll put a little g next to it. It's called acceleration due to gravity. I think it confuses me. I just avoid that because I like to think about the ball, right? And the ball is the one that's acceleration. So if I write g, it sometimes confuses me. But acceleration due to gravity on the ball is what it's basically saying. Anyways, what is the final velocity? We need to figure that out, right? Right before it hits the ground. What is that velocity? What's the initial position? Well, the initial position is it is 10 meters above the ground. So if this, and you can say anything is the ground, but I'm going to say this is the ground. So if this is the ground, then this is now 10 meters above. And what's the final position? Well, the final position we know is going to be 0 meters, right? Like right before it hits the ground, it's basically 0 meters. So you can just say 0. And then how long does it take? That we don't know. So our goal is to figure out V final. So again, every problem will give you certain variables. This time it wasn't so direct, but we figured it out slowly. And now to get the other variables, the remaining, use your equations. So how do I get V final? Well, there are only 2 equations that have V final. V final equals V initial plus AT. Let's write them all out. Delta x equals VIT plus 1/2 AT squared. Notice, no V final in this equation, so you cannot use this equation to get your V final. Okay? And then last is V final squared minus V initial squared equals 2A delta x. So which one should we use? Well, if we use this one, right, on top, we need to have time, and we don't have time right now. So let's use the other one. Okay, and this is literally how you do physics. It's like there's no fast way of doing it. You have to go one by one. You have to say, well, this one has no V final. This one you have to see, do you have all the variables? Oh, I don't have time. Okay, then I'm going to go down here. So V final squared minus the initial velocity is 0 equals 2 times negative 9.8, and then delta x, you're going from final minus initial, right? So 0 minus 10. So notice your change in distance is actually going to be negative 10, right? Because you're starting here and then you're going down. So I think that makes pretty intuitive sense. That what's my change in distance? I went down 10, basically what I'm saying, right? So I'm going negative 10. So you can think of it as final minus initial, or you can just look at the picture and be like, I'm going down 10. And I usually do both. I use the formula just to stay safe and then double check with intuition. Anyways, so what is V final squared? It is this. whatever this is. 2 times negative 9.8 is negative 19.6 times negative 10 is 196. So V final, I'm going to bring it up here. So V final is the square root of 196, and which is 14. And you might think, I am done. I've gotten my answer, 14. However, remember from back in the day, middle school, when you take the square root of a number, okay, you're actually taking the plus or minus, right? Because the answer is not just 14, it's plus or minus 14. And that's important because this is your answer. V final is plus or minus 14. And then you have to ask yourself, well, is it plus or is it minus? Well, you tell me. If my ball is going down, right? It starts, you drop the ball and it's going down the whole time. So the direction is down. So which one is it? Is it positive or negative? Well, my V final is right before it hits the ground, right? Which is going to be there. It's still going down. So the V final is actually negative 14 meters per second. See how that's a little tricky, right? It's going to trip people up because you might just write positive 14, but you always have to ask yourself in physics, does the positive or negative make sense? And we should actually, from now on, I'm going to be more stickler about this. Every time I write down one of these variables, I'm going to double check, does the sign make sense? Does it make sense that it's positive and does it make sense that it's negative? And we're going to have to double check every time. You have to be a little bit paranoid about it, honestly, to get it perfect. So V final is negative 14 because the speed is 14 and it's going down, therefore it is negative. Cool. So we got our V final. What is our time? Time we can now figure out from this equation because it has time in it, or this equation down here also has time. And look, we have every variable. So we can use either one, right? This last equation does not have time. There's no time. So use those little shortcuts I told you in the beginning. There's no time, so we can use this one or we can use this one. This one is shorter, so I'm going to use this one, right? This one looks just long and ugly. So V final, which we just figured out, is negative 14. So let's get rid of the question mark. It is now negative 14. So V final equals V initial, 0, plus acceleration, negative 9.8, times time. So 14 divided by, negative 14 divided by negative 9.8, whatever that is. I think it's about 1.5 seconds. Right? So there you go.